Hello viewers, in today's session we are going to discuss another important problem from Dirac delta function, right? And here we are going to find out the Laplace transform of this delta function, that is delta of minus pi t plus 1, right? So we'll find out the Laplace transform of this delta function using an important property of delta function. So let us first define the Laplace transform of some function, say f of t, right? So the Laplace transform of the function f of t is given by this integral, that is 0 to infinity. We have e raised to minus s times t, and here we have f of t dt, right? So here we can take this function as f of t. So the Laplace transform of this delta function is now given by this integral 0 to infinity e raised to minus st, and f of t may be replaced by this delta function, that is delta of minus pi t plus 1, and here we have dt, right? So now we have to find out the value of this integral using the definition and property of Dirac delta function. So now we have an important property of delta function, that is delta of ax is given by 1 over the absolute value of a, and here we have delta of x, right? And here a is not equal to 0. So delta of ax is given by 1 over absolute value of a times delta of x, right? So now we can also write a modified version of this property, that is delta of, say, ax minus b can also be written as delta of, here we can take a common between ax and b, so we have x minus b over a. So now we can apply this property to this expression. So we have here a, so we can now write 1 over absolute value of a and delta of x minus b over a, right? So here we have delta of minus pi t plus 1, and will apply this property to this delta function. So now delta of minus pi t plus 1 can be written as delta, and here we can take minus pi common between minus pi t plus 1, right? So here we have t, and then we have a negative sign here because negative and negative becomes here positive, and we have 1 over pi, right? So now this delta function is similar to this one, and here the value of a is minus pi, right? So applying this property, we have 1 over mod of minus pi, and then we have delta of t minus 1 over pi, right? And mod of minus pi is equal to simply pi, so we have 1 over pi delta of t minus 1 over pi. So now replacing delta of minus pi t plus 1 by this expression over here, the Laplace transform of delta function is now given by 0 to infinity e raised to minus st, and here we have 1 over pi and delta of t minus 1 over pi, and here we have dt, right? And 1 over pi is a constant, we can take it outside the integral. We have 0 to infinity e raised to minus st, and we have delta of t minus 1 over pi, and here we have dt. So now here we can see that we have this function e raised to minus st, and here we have delta of t minus 1 over pi. So we can evaluate this integral by using the definition of delta function, that is minus infinity to infinity. We have, say, f of x, and here we have delta of x minus a dx. Then the value of this integral is given by the value of the function f of x at this point, that is a, right? So we have f of a. So here we have this function, and the value of a is given by 1 over pi, right? So the value of this integral is equal to the value of this function, that is e raised to minus st at this point, that is t is equal to 1 over pi, right? Because 1 over pi, it belongs to this interval, that is the limits, that is 0 to infinity, right? So now we have 1 over pi and e raised to minus s times t. Taking t is equal to 1 over pi, here we have minus s times 1 over pi, right? So this is 1 over pi, and taking this term to the denominator, we have e raised to positive s over pi, right? So this is the required Laplace transform of this delta function. Hello viewers, in today's session we are going to discuss another important problem from Dirac delta function. So here we have to find out the value of this integral involving the delta function. So we have the integral from minus pi to pi t raised to 4 and delta of t square minus 2 dt, right? So here we'll solve this integral with the help of one important property of Dirac delta function, right? So let us first will state the property, and then we'll see how we can apply that property to simplify this integral. So let us start. So let us first call this integral as I, and we can write this integral as minus pi to pi, and here we have t raised to 4, and here we can write this delta function as t square minus is the square root of the square root of 2, right? So here we have used this fact that 2 is equal to the square of under root of 2, right? So expressing t square minus 2 like this, because we are going to use this important property of delta function, which says that delta of x square minus a square is given by 1 over 2 times the absolute value of a, and then here we have delta of x minus a plus delta of x plus a, right? So this is the property which we are going to use to solve this integral. So now let us apply this property to this delta function. So we have here integral from minus pi to pi, then t raised to 4, and delta of t square minus root 2 square can be written with the help of this expression. So if we compare these two expressions, then the value of a is the square root of 2, right? So now this delta function is equal to 1 over 2 times the absolute value of square root of 2, and then we have delta of x minus a. So here the variable is t, so we can write t minus a. A is square root of 2, then we have delta of t plus square root of 2, right? And here we have dt. So now the absolute value of square root of 2 is simply square root of 2. So we can take 1 over 2 times square root of 2 outside the integral, and we have minus pi to pi t raised to 4, and this expression, that is delta t minus square root of 2 and delta t plus square root of 2, and here we have dt, right? So now let us write this expression or this integral as a sum of two integrals. So now we can write 1 over 2 times square root of 2. So the first integral is from minus pi to pi t raised to 4 delta of t minus square root of 2. Right, here we have dt, and then the second integral is from minus pi to pi t raised to 4, and here we have delta of t plus square root of 2, and here we have dt. So now we have two integrals involving the delta function. So to evaluate these two integrals, we'll make use of this definition of delta function, that is integral minus infinity to infinity. We have f of x delta of x minus a dx, right? So whenever we have a function f of x associated with the delta function, then the value of this integral is equal to the value of the function f of x at this point, that is x is equal to a, right? Because the delta function is 0 everywhere except at this point x is equal to a. So here we have f of a. Now here the limits of integration or the bounds are given by minus pi and pi. Here also we have minus pi and pi, right? And here we have t minus square root of 2. So here the value of this a is square root of 2, that is approximately 1.414, right? And here the value of a is given by negative square root of 2, right? And this is minus 1.414, and we can easily see that these two numbers, that is square root of 2 and minus square root of 2, they fall within these bounds, that is minus pi and pi, right? So if we draw the number line like this, here we have 0, and here we have say minus pi, and here we have plus pi. The approximate value of pi is 3.14, so this is minus pi, here we have plus 3.14, and 1.414, it lies somewhere here. So here we have square root of 2, and here we have minus square root of 2, right? So we can write that square root of 2 and minus square root of 2 both belongs to this interval, that is minus pi to pi. So the value of this integral is equal to the value of this function t raised to 4 at this point. And similarly, the value of this integral is given by the value of this function t raised to 4 at this point, that is minus square root of 2, due to this definition, because here at this point x is equal to a lies within these two bounds, right? So here we may have different limits instead of minus infinity to infinity, right? So now the value of this entire expression can be written as 1 over 2 root 2, and here the value of this integral is root 2 raised to 4, and then here we have minus root 2 raised to 4, right? So we have 1 over 2 times the square root of 2, and the fourth power of square root of 2 is equal to 4, right? And here also we have 4, so this is 8 over 2 times square root of 2. So this is 2 times 4. So we have 4 over square root of 2, and rationalizing the numerator and denominator, we have 4 root 2 over 2. So this is 2 times square root of 2, right? So viewers, the value of this integral is given by 2 times square root of 2.